Linear and nonlinear systems of equations. Linear systems of equations. The first way that we can solve a system of equations is by graphing. Now, in this course, we are only going to use graphing to verify a result that we found algebraically, which is using substitution or elimination, but it is a great way to verify your result. So 2x plus y equals 5. Notice I don't have to put that into slope-intercept form. And 5x minus y equals 9. And then I can just click on that point to find the point of intersection. Now, we know the result is going to be 2, 1. So now we're going to look at the algebraic ways to solve this system and verify that we also find that it's 2, 1 using those ways. We're going to look at both solving a system using elimination and using substitution. Now, I want to point out that your textbook only covers substitution, but elimination is a valid method, and you'll want to use it when you have the situation where you have one variable that has the same coefficient in each equation, but the opposite sign, or you can get it there very easily. So for instance, in this system of equations, I have a positive 1y and I have a negative 1y. So that's the same coefficient but the opposite sign. So I don't have to do step 1. I don't have to manipulate either equation. It's already in that form. Step 2 says add the equations together so that one variable is eliminated. 2x plus 5x is 7x. 1y plus negative 1y eliminates, and that's why it's called elimination. And then 5 plus 9 is 14. Then I'm simply going to solve that equation obtained in step 2. So divide by 7, get x is equal to 2. Then we're going to back substitute the value obtained in step 3, which is this value. I'm going to put it back into either one of my original equations, and it doesn't matter which, so it's whichever one you want to do. So I'm going to do both of them in this case, just so you can see that they're going to be the same. 2x plus y equals 5. That's 4 plus y equals 5. Subtract 4, y is 1. Or 5 times 2 minus y is equal to 9. 10 minus y is equal to 9. Negative y is equal to negative 1, so y is equal to 1. And either way, I'm going to get the same solution, and that solution is 2, 1. Now, that was step 4. So step 5 says check that the solution satisfies each of the original equations. And I kind of just did that because I plugged it into both of the original equations. I already know that when I plug in 2, I get 1 for both of those equations. Now let's take a look at substitution. And again, this is the method preferred by your text. The method of substitution is you're going to essentially get one variable isolated. And it doesn't matter which one that you do. In this case, it would make sense for me to isolate y in either equation. So I'm going to go ahead and take this first equation. 2x plus y is equal to 5. I'm going to subtract 2x from each side to get y is equal to negative 2x plus 5, or you could write that 5 minus 2x. So that's step 1, is to solve one of the equations for one variable in terms of the other. So that means isolate one variable and write it, in this case, in terms of x. 2, substitute, which is why it's called substitution, that expression in for the variable in the other equation. So now I'm going to take the other equation, 5x minus negative 2x plus 5 is equal to 9. So I'm replacing y with negative 2x plus 5. Now I have a minus, so I'm going to change the signs so that I don't get confused. So that gives me 5x minus negative 2x, which is plus 2x, or 7x. And then I have minus 5 is equal to 9. I'm going to add 5 to each side, and I'm going to get x is equal to 2 by dividing by 7, which is, as we know, the solution. So that's substitute, solve, we've done all of that. We found the value for x. Step 4 is to back substitute. Now, just as we did in our last question, you can use either of these two equations to plug into, but you can also use that equation that you manipulated. It's going to save just a little bit of work. So -2 times 2 plus 5 equals -4 plus 5 equals 1. So 2, 1 is again my solution. I have one question for you to try on your own, and that is to use either substitution or elimination and then check your work with graphing. And feel free to use both if you just want to test out your abilities. When you are ready, press play to see how you did. So if you're using substitution, a lot of students try to take this equation and get x by itself. But the easiest way to use substitution is because y is already isolated, I'm just going to take this expression, which is equal to y, and plug it in for y in the other equation. So this is going to be my first step. Then I'm going to subtract 2x from each side. Now remember, when you're subtracting with fractions, instead of subtracting 2x, I'm thinking about that as -4 halves x and combining that with -1/2 x to get -5 halves x. Subtract 3 from each side, and then remember, when you're dealing with a fraction, instead of having to multiply each side by 2 and then divide by 5, I can just multiply by the reciprocal, -2/5, and find that my solution is -2 for x. Don't forget to plug it back in to find y. So again, use either equation. I'm choosing y equals 2x plus 8, replacing x with -2. That gives me -4 plus 8 or +4. And then write your solution as an ordered pair. I can't tell you how many times students forget to do that last very important step, -2, 4. Now, if you're using elimination, you can obviously say take everything here times 2, and that would work just fine. But one way you can do it is just to negate everything in one of the equations, and then when I add them together, those y's will go away. So I'm going to have 0 is equal to 5 halves x plus 5. So again, elimination, I've negated the second equation, I've added them together to get 0 equals 5 halves x plus 5, subtract the 5 halves x from each side, again multiply by -2/5 to get x is -2, and then I would just repeat this process to find that y is equal to 4. And then, of course, check your result by graphing. So when I graphed those two equations, I found -2, 4. Nonlinear systems of equations. Let's take a look now at nonlinear systems. So to review, we've just learned or relearned substitution, elimination, and graphing for a linear system. And we did the same example each time, but I do want to point out that when you solve a linear system, you're either going to have, let me change colors there. You're either going to have two lines that intersect at just one point, so you're going to have one solution, or you're going to have two lines that are parallel, which means no solution, which is also called inconsistent. Or you're going to have two lines that are basically drawn on top of one another, which means you're going to have a consistent system, but you're going to have infinitely many solutions. Now dealing with a nonlinear system. So in this case, I've got a parabola, and I can tell it's going to be parabola because it's quadratic, the degree is 2. And I have a line, so the degree is 1. So I can see I'm either going to end up with 0 solutions if that line doesn't cross through the parabola. I'm going to have just one solution if it's tangent to that point or crosses at just one point. Or, whoops, lost my parabola. Or I'm going to have two solutions if it crosses through the parabola twice. Now, of course, we can keep going through and looking at a quartic equation or a quintic equation or whatever and see how many lines or points we could have, but we're not going to get too crazy in a pre-calculus class. So let's take a look at how to solve this. Good news is you already know how to do it. You can use substitution or you can use elimination, whichever one you like best. I am going to use substitution simply because y is already isolated. So I'm going to use that second equation, x plus y is equal to -4. I'm replacing y with everything that y is equal to. 2x squared minus 3x minus 8. And then I have equals -4. Let's simplify. On the left, I have 2x squared. I've got a +1 and a -3x. That's -2x. And I have minus 8 is equal to -4. Let's add that 4 over. Whoops. -2x squared minus 2x. I'm going to add 4 to each side so that I have now an equation that I can use. I can use factoring or the quadratic formula. I'm going to choose to factor. I'm going to start by factoring out of 2 because everything is even. And then I'm going to look for multiples of 2, or I'm sorry, factors of 2 with a difference of 1, which would be -2 and +1, which means I now have two x values. X is +2 and x is -1. Now remember, the rule is now that I have the x values, I get to choose which equation to plug the x back into. So I'm no fool. I want to do as little work as possible. I'm going to choose that linear equation because it's less math. So x plus y is equal to -4. I'm replacing x with 2. 2 plus y is -4. Subtract 2 from each side, I get -6. So that point is 2, -6. And then -1 plus y is -4. Add 1 to each side, y is equal to -3. So that point is -1, -3. As always, open up your browser, get out your Desmos, plug it in, and see what happens. And I get 2, -6 and -1,3. Here's one for you to try on your own. So I would like you to press pause, try this question using either substitution or elimination, and then press play to see how you did. So I'm going to go through using the method of substitution, but I do want to point out it would also be very easy to use elimination. I would simply change the sign of everything in that second equation and then add these together to get 3x squared, and then +4x -2x gives me +2x. Plus y minus y cancels, and then 7 plus 1 is 8. And then I would continue from there to be able to solve. But I used substitution instead. So I rewrote that second equation. I'm going to get rid of all of this except for that final part. Rewrote 2x minus y equals -1 as y equals 2x plus 1. And then I plugged that in for y in the second equation. And as always, be careful when you have a subtraction sign in front of something in parentheses. Make sure that negative gets distributed to everything. So I have 3x squared plus 4x minus 2x minus 1, and then I subtracted 7 from each side on the same step. Simplified, and I want you to notice that this is the equation which I would then simplify to 3x squared plus 2x minus 8 is equal to 0. These equations are the same. So once you get to this point, it's the same process. This I factored into 3x minus 4, x plus 2 to find my two x values, and then of course I plugged them in to find my y values, which is 4/3, -11, 4/3, comma 11/3, and -2, comma -3. We're going to take a look at one application question involving the break-even point. The break-even point when you're dealing with cost and revenue is where the cost is equal to the revenue. That's where the company goes from losing money to making money. what we need to do is we need to read what we know about this company. We need to write the system of equations, and then we need to solve it algebraically, and of course, use graphing to verify our result. So we'll begin by taking a look at the equations that we will produce. We'll start with the cost equation. The cost equation represents anything that is a cost to the company. So we have a shoe company that invests $150,000. That's going to go in my cost equation. In equipment to produce a new line of athletic footwear, each pair of shoes costs $10. So that's $10 for each pair, so that's 10x, where x represents the number of pairs of shoes. And it sells for $90. Well, that is going to be towards our revenue. That's money that is coming in. Every time we sell a pair of shoes, we get $90. From here, I now have a system of equations. So instead of C and R, I'm just going to write both as y equals, and just remember that this is cost and this is revenue. And to solve the system, you can use substitution or elimination. And so I'm going to use substitution because that's an easy way to go about it here. I'm going to get 90x is equal to 150,000 plus 10x. Subtract 10x from each side to get 80x is equal to 150,000. Divide each side by 80 to get x is equal to 1,875. To find, and this represents the number of shoes. So if it says, how many pair of shoes, which is what we're asked to do, that's where I stop. I would say, yep, 1,875 pair of shoes. Now, if it also said, and what is the cost / revenue at that point, well, that's when I would plug it back in and say y is equal to 90x, or 90 times 1,875. And I would end up with the revenue and cost where they're equal to be 168,750. And then I of course would graph that equation to ensure that I did the math correctly. Up next is section 7.2, two variable systems.